All right, good morning. First off today, we are going to be using composition to do something new, but before we get into the new stuff, let's review what operations and compositions are. So if you've forgotten your notation, remember we can do sum, difference, product, and quotient of our different functions, as well as composition, which is where I'm substituting one function into another. So let's just jump right into some examples. On example 1, I've got a set of values for my two functions f and g. So the first part A wants me to find f of 1. So this is saying for my f function, when x is 1, what is y? So I'm going to go to the ordered pair. Remember, it's x comma y. So when x is 1, y is negative 1, which means f of 1 is negative 1. On part B, I'm doing something similar, but I'm looking for g of negative 1. So I'm going to go to the g function and look for where x is negative 1, and that's this ordered pair here. And when x is negative 1, y is negative 2. So g of negative 1 is negative 2. Now lastly, on part C, remember that open circle means composition. So I want to find g of f of 1. So what I'm going to do is rewrite this in my alternate composition notation so that I can more clearly see what it is I'm doing. And I'm just going to work from the inside out. Now on the very inside I have f of 1. I know what f of 1 is from part A, and that is negative 1. So now what I'm looking for is g of negative 1, which I know from part B is negative 2. And that is my final answer. So we can also use composition with an XY table or a set of ordered pairs. Moving on to example 2. I've got my two functions, and this is the product, so I'm going to be multiplying them. So I'm going to take x squared plus 6x minus 16 and multiplying x plus 8. So remember, if I've got a 3-term and a 2-term, that means I'm going to be doing multiplication 6 times. And then the last thing I'm going to do is combine my like terms. And that is all I have to do. On example 3, 2 new functions, and here I'm subtracting. So remember, what's important is that I'm putting my second function in parentheses because I need to distribute this minus sign. If I don't have the parentheses there, I'm likely to forget that I need to do that. And then I'm just going to combine my like terms. And that is easy peasy, lemon squeezy. On to the back page. On number 4, again, I have another composition. I'm looking for f of g of 4. So working from the inside out, the first thing I want to find is g of 4. So I'm going to plug 4 into the function for g. And I'm going to get 16 minus 4 minus 5, which is 7. So now that I know g of 4 is 7, what I'm left looking for is f of 7. So I'm going to plug 7 into the f function. Negative 21 minus 14, which is negative 35. And that is my final answer. Okay, last one on our recap. I'm looking for 2 times g of f. So what that means is I'm going to substitute f into g, and I'm going to multiply that result by 2. So 2 times, and now I'm going to plug this entire function f into both places where I have an x in the other function. So that's going to be 3 times x plus 5 squared minus 7 times x plus 5 plus 4. So I'm going to simplify what's inside my brackets first, and then at the very end just multiply by 2. So exponents first, remember this means we're foiling. This is x plus 5 times x plus 5. So that's going to give us x squared plus 10x plus 25. And now I can go ahead and do my first distribution of multiplication. I'm going to consolidate inside my brackets. And then lastly, just distribute that too. And there is our final answer. So now that we're comfortable with these operations and a refresher on composition, let's talk about one of the uses of composition. I use composition to determine whether two functions are inverses of each other. So if I have two functions f and g, if I substitute g into f and my end result is just x by itself, and I substitute f into g, and my result is just x by itself, then these two functions are inverses of each other. This notation, your f to the -1, that is the notation for inverse. So when you see a function to the -1 power, that means we're looking for the inverse, or you're asking about the inverse. So what inverse functions do is they undo each other, and we're basically swapping our x's and our y's. So next time we'll get into how to find an inverse when you're given a function. Today we're just going to talk about confirming if it's an inverse. So again, I need to do composition both ways, just one is not enough, and you're looking to get x as your result. So let's dive right into an example and see how that works. So on A, I've got two functions, and I'm going to use composition to say if they're inverses of each other. So the first thing I'm going to do is plug g into f, so I'm looking for the composition f of g. So I'm going to take my entire function g and substitute it in place of x. So 1 minus 2 times 1 minus x over 2. Now I'm going to go through simplifying, and then whatever my result is going to tell me whether or not this could be inverses. So 1 minus, these 2's are going to cancel, so I'll be left with just 1 minus x. And then I need to distribute that negative. 1 minus 1 plus x. 1 and -1 cancel, and I'm just left with x as a result. So the first time I did the composition, it works, but we have to check it the other way as well. So this time, I'm going to take g of f, and I'm going to plug my entire function f here into g. So 1 minus 2x over 2. Need to distribute that negative in the top. 1 minus 1 plus 2x divided by 2. 1 and -1 add to 0, so I'm left with 2x divided by 2, which is x. So yes, they are inverses because when I did composition both ways, my end result was just x by itself. If you get anything else, they are not inverses. Let's do that once again on example B. Again, two functions, we're going to do composition both ways. Let's do f of g first. So I'm going to take all of g and plug it in right here for x. So 1/4 times 12 plus 4x minus 3. I'm going to distribute that 1/4. 1/4 times 12 is 3. 1/4 times 4 is just going to give me x. Then I still have that minus 3 on the outside. 3 and -3 add to 0. So my end result is just x, which is what we're hoping to see. Now I have to do it the other way. G of f. So I'm going to take all of my f function and plug it in place of x in my g. And I'm going to distribute the 4. 4 times 1/4 is 1. 4 times -3 is -12. The 12 and the -12 add to 0, and I'm left with just x. So yes, these are also inverses of each other. And then I've just got one more example for today. On example C, I'm looking at, again, f and g. Let's start composition one way. So plugging this whole thing into x. 1/3 x plus 2 minus 2. So that's going to give me x plus 6 minus 2, and my result is x plus 4. This is not x by itself, so I already know that these are not going to be inverses of each other. But just for the extra practice and so that you can see the other way, let's do the composition g of f as well to see what we get. So 1/3 times 3x minus 2 plus 2. That's going to give me x minus 2/3 plus 2, and I get x plus 4/3, which again is not x, so no, those two functions are not inverses of each other. So when you are confirming, you have to do composition both ways, and if you get anything other than x, then they are not inverses. If both compositions give you x, then they, are inverses.